Okay, welcome to the fourth episode of the tiled maps in LibGDX series. And yeah, now it's 6 episodes again, I can't decide. Um, so today we are actually going to take care of the collision detection. And I think this episode might get a little bit longer than 15 minutes, maybe even 30. But I'll try to keep it short. So, to keep it short, I should actually begin. The first thing that we have to take care of, if we want to do collision detection, is we have to define what should actually be a tile that collides. So let's go into the tiled map. Actually in the tiled map editor. Yes. Yes. Fine. And we see that in the tiles down here, we can select which tiles should collide. So let's just say these here collide. Actually, no, that's a bad example. Let's say the cave down there collides, okay? So to do this, we go onto the cave tiles, and we say we can actually right-click on these in the tile set down here, and set tile properties to them. So these tile properties is what I was talking about, the map properties that everything in the map API has in code. So let's set a new property and just say blocked. We don't have to set a value, because we can just say everything that has this property blocked is blocked, and the value doesn't matter at all. So now we have this tile here blocked. We actually want to block all of them. Can I select them and then say blocked? Nope, I have to do it for every single thing. So copy blocked, 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 and blocked one more time. I'm not gonna block the door because you could walk in it and whatever. Actually, this is a bad example for a side scroller, isn't it? It kinda is, because yeah, let's actually just say this one here is blocked, this weird stone here, and create some place to walk around. Yeah, absolutely great. Maybe some of these. Okay, this totally doesn't fit. This is a top-down map now, and this is a platformer part, but who cares? So save this, and we have to refresh the project here. Refresh. And let's actually clear it as well, just to be sure. And yeah. Now we can go ahead and put this collision detection in the player. So what is the idea of the collision detection? Let me just show this concept, the idea, in comments. So the idea is to, at first, we want to have some variables called old x equals the current x, and old y equals the current y, and that's actually it. And we want to move the player to the new position, like doing right here, and then check if that position is a position where it collides with something, and if it collides, we want to move it back to the old position. There is a bunch of ways you can do it, but this is the way we are going to do it. Alright, so we actually have to separate the y and the x, because we have to check it after each step. Yeah. Move on x, move on y, save old position, and after we moved on x, we want to check what's happening, if we're on a tile that collides. So now it's getting a little bit complicated. There is two ways that we can move on the x direction, and that is to the left and to the right. So we want to at first separate these two cases. If velocity.x is smaller than 0, which means if we're going to the left, we want to do this stuff here, and else if it is greater than 0, we want to do this stuff. If it's 0, we don't want to check the x at all, obviously. So great. Then we also want to do the same stuff here on the y. If that's smaller than 0, which means we're going to the bottom, falling down, and if it's greater than 0. Okay, so it would be simple to just take all the tiles and see if the player is on one of them and collides with it, but that's kind of not so performance-wise. Just imagine you have like a map with 500 times 500 times the tiles, and you have to check just for the player if he collides with any of these. That's crazy. So there's a better method, and that is to separate at first these cases here where we're going. So we can already determine that if we're going left, we're just going to need tiles that are on the left side of the player, and if we're going right, just the tiles that are on the right side of the player. Same with up and down. And yeah, then we just need three tiles that the player can collide with. Just imagine it like, let me show you the tile map. If the player is standing right here, okay? If the player is standing here and he's going left, we want to check at first, is there a tile in any of these three that collides? Yeah, that's pretty much the way I can explain it. If he's falling down, we want to see if these three are here. We could actually just check for the one under him, the one on the left, the one on the right, and the one on the top. But then imagine the player doesn't always go in these four directions. He could also be jumping in such a way, and then he would not be coming straight from the top. So we actually need to check the diagonal tiles as well. Yeah, I hope you got the idea of this. So let's set this up with comments. At first, if the velocity is smaller than 0 on the x-axis, that means we're going to go left, which means, have a look, we're on this position. If we're going left, we have to check the tile on the left top, the top left, the top middle, and the top bottom. The top? What am I talking about? The left. You know what I mean. We have to check on the top left, we have to check on the middle left, and we have to check on the bottom left. That's what I mean, okay? So let's set up these checks. So how do we actually check? What do we actually want to check? We want to actually get this tile here for the top left, and then we want to see if this tile has this property blocked. So if we can walk through it or if we can't. And yeah, we can't. In this case we can, here we couldn't. So to get this tile, we actually have to have something to get this tile from. We cannot get it from nothing. And right now this player has nothing to get it from. So we want to put one more thing into his constructor, which is called a tiled map tile layer, called collision layer. And this is going to be the layer that the player takes care of. Yeah, where he checks his collision. So let's put this one up here. And set this one. And then down here we can do some handy stuff with this. Let's actually set up some variables, some more. Like here we want to have two booleans. The first one is going to be a boolean if we collide it on the x-axis, and the second one is going to be a boolean if we collide it on the y-axis. Actually, let's call these collided x, collided y. Actually, let's call them collision x equals false at first, and collision y equals false at first too. So now we want to set these. Collision x equals, and now there comes a pretty long line. Okay, so we want to get, remember, we want to get the tiles on the left side of the player from this collision layer. So let's say collision layer dot get cell, and we want to get the cell at what position? At the position of the player, pretty much, of the top left corner. So the top left corner is the x position of the player, and on the y it's the y position on the player plus the height of the player. But this is not working like this. At first, the tiled map, this get cell is taking stuff in tiles, so we cannot just pass in the actual position. We have to convert that to the tile position, like this here. This is, you see it down here, what position this is, and yeah, this is not how the player moves. The player moves smoothly, the tiles kinda don't. So let's get some more variables up here. The first one is gonna be called tile width, and this is gonna equal collision layer dot get tile width, and tile height, which is going to equal collision layer dot get tile height. So now we can go ahead and divide these by tile width, and these two by tile height. Still, this one is having problems because we have to cast that into an integer. That's already a lot of parentheses, but it's going to get even crazier. Collision x is a boolean, and this is a cell, so we cannot convert from a cell to a boolean. That makes no sense at all. We have to get the tile that is actually in this cell. And from that tile we can get the properties, which is this map properties class that I said everything has. The map has it, the tile layers has it, and yeah, the tiles have it as well. So there we go, the properties for the tiles. And then we can see if it contains the key blocked. So this is a long line, isn't it? Let's actually break this down a little bit. Yeah, this is enough. So we're going to the collision layer. We are getting the cell at the position of the player divided by the tile width, so we get the position of the tile in tiles. The same for the y. On the top left, this is why we add the height of the player. And of course divide everything by tile height. And then we get the tile in that cell, get the properties of this tile, which is this, the properties of the tile. Here are the properties of the tile, and these in name are the keys, and in value, well, they are obviously the values. So we are checking if this tile has the property, the key blocked, and there we see, in this case it has the key blocked. We don't know what it's going to be like in this case here, but anyway, we're getting the properties and we're seeing if it contains the key blocked. We just have to do that a couple of more times. We have to do this for the middle left and for the bottom left. Collision x equals collision layer dot get cell, which we have to cast into an integer. Get x middle left, okay, middle left, yep. Get x divided by tile width, and because it's the middle, we get the y, and we add the height divided by 2 to it, and we have to take all of this divided by tile height. Then we have to get the tile, to get the properties of the tile, and check if it contains the blocked key again. The same thing happens for the bottom left. Collision x equals collision layer dot get cell int the bottom left is get x divided by tile width, and get y divided by tile height. Then we have to get the tile again, get the properties, contains, it checks if it contains the blocked key, and that's it. So there's still something wrong with this. Right now we are setting this 3 times. So imagine that the top left would collide, collision x would be set to true, and then the middle left doesn't collide, it would be set to false again, and this one doesn't collide as well, so it would be set to false again, even though it does collide on the top. So we could make it simple for us and just say this is a bitwise operator. I'm a fan of these, but yeah, this is an OR, so if one of these arguments is true, if the right side or the left side is true, it's going to be true. So if one of them is already true, we are not going to lose the true. But we can actually say if there is no collision yet on that axis, we want to check if there is a collision. This way we don't have to check it if it's true right here. We don't even have to check for the middle and the bottom left. So we see if it collides on the top left. If it didn't collide yet, we check if it collides on the middle left, and if it still didn't collide, we check if it collides on the bottom left, and if it then still didn't collide, there is no collision and we can move. So this is already a long episode, isn't it? Oh yes, it is. So right now we just have to do this for all the other sides. If we're moving to the right direction, we are moving to top, where we have to check the top right, we have to check the middle right, and we have to check the bottom right. Collision x equals collision layer dot get cell int what, some parentheses, thank you. The top right is get x plus get width, taking these two, and we have to divide them by tile width, and since it's the top, it's get y plus get height, and take these two and divide them by tile height again, then get the tile, get the properties, check if it contains the blocked key. If it still didn't collide, collision x, then we check if it does. Collision x, oh god, I can't type. Collision layer dot get cell, setting up the casting. Get x middle right is on the right, so get width. take this and divide them by tile width. Get middle, so get y plus get width divided by 2. Take these and divide them by tile. Actually, right there, divide them by tile height. Get the tile, get the properties, check. My fingers fall off. And if it still didn't collide, collision X. Heck, I'm not going to write this all again. I'm just going to modify the variables now. Bottom right is get x plus get width divided by tile width. Bottom right, yes. And since it's the bottom, we don't need to add anything to the y. Eclipse removes the parentheses for me automatically, and that's it. So now we have to do the same thing on the y-axis. If we are moving downwards, we have to check the bottom left, the bottom middle, and the bottom right. In case of bottom left, we want to say collision y equals collision layer blah 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 blah. Bottom left is on the left, so just get x. And bottom, so also just get y. Then if there is no collision on the y-axis yet, bottom middle, so get width divided by 2, and bottom. And if collision y still didn't happen, maybe it does now. The bottom right, get x plus get width, correct, but it's the bottom. Is that true? Yeah. Yeah, it's okay. I already thought I did something wrong. Now for the case that we are going up, left, actually top left, collision y equals collision layer blah blah blah. Top left, so we don't need to add the width. And what am I doing here? I'm seeing a get y plus get width. This is not good. Let's check. Get y plus get width is going to be replaced by get y plus get height. Yep, it happened 2 times. Now it's fixed. So this is the top left. So not divide by 2. And fine. Fine, I hope. If collision y didn't happen yet, collision y equals stuff. This is the nope, wait. We're going up, so it's the top middle. Whatever. Yeah, that's correct. We divide by 2 right here, and we I already did get width again because I copied it wrong. Get height. What? Top middle. Get height divided by 2. That's correct. Let's copy this for now. Actually, the whole line. And the top right. If it didn't collide yet, then maybe it does now. Oh, not divide by 2 here, that's the top. And collision Y, also not divide by 2 here. And we were gonna go straight to the right. Alright, so now we got all of these set up. Now we just have to react correctly. How long did this take? Oh god, this took around 6 minutes. I have to cut this. Anyway, okay, so now we have set if we collide on the x-axis and if we collide on the y-axis. Let's react to this properly. Before we move on the y-axis, we want to correct the x-axis. So we can say if there happened a collision on the x-axis, we want to at first set the x to the old x again. So it is like we didn't move because we couldn't move there. And the velocity.x is going to equal 0 because if you run against the wall, you also don't have any velocity anymore. React to x collision, and down here we moved, we check for the collision, and then we react to y collision. If collision y, then we wanna, what do we wanna do? Collision y, blah blah blah. Yeah, set y to the old y, and velocity dot y equals 0. Great. So now we have the player. It can fall around. Let's test it out. At first we have to give this one, we changed the constructor because we wanted a tilemap tile layer on which the collision should be checked. So we have to give it in here, and that is actually map.getLayers, and we just have one layer anyway, so let's just get the first one. And we have to cast this to a tiled map tile layer. Right now it's just a tile layer, but now we cast it to a tilemap tile layer, which we have to import. Alright. The player should be set to another position because we said this is where we have the colliding stuff happening. So let's say we move it like here. This is, we see it in the bottom left corner, the position 1138. So let's move it to 1138, but remember we have to take this times the player.get collision layer. Okay, let's add this one. Or we can let's just add it. Some getters and setters are always good. Collision layer, gravity, speed, and velocity for everything. Jip, jip, jip. We don't need Javadoc on this. It's just taking some space. Alright. So now we can say player.get collision layer dot get tile width, right? And here also times the tile height, player.get collision layer dot get tile height. So yeah, the player takes this collision layer from right here. We could also store it here and then whatever, but this way we have this in 2 lines. Okay. I'm really excited if this is going to work, because if it isn't working, I can record the whole episode again. So I pray to God now that it's working. Let's just... Holy shit. Holy... Oh god, it's working. The position was somewhere else, but who cares? It's working. Do you see it? He's standing right there. Fuck yes. One more time. He's falling down from some invalid position, but who cares? And there he is. Epic. Actually 38 is wrong, because this here has a y down coordinate system. You see that on the top we have 0, 0, and down here we have 0, 49, because this is 50 tiles wide. So we have to convert this from the one system to the other. And 38 would be in our system. Let me get a calculator. Actually, we can calculate that in code. 38, we want to set it to the 38 in the y down. So we say player dot get collision layer dot get height minus 38. And take this times the tile height. I think it's not going to work, I guess. It actually did work. Cool, I'm a mathematical genius. So right, sorry that this episode got so long, but we've now got the collision detection. We can't really test it because we cannot move around, but who cares? We got gravity, we got the collision detection, and then in the next episode we are actually going to let the player move around a little bit. Thanks for watching this whole long episode, and yeah, I hope you understood this. If you didn't understand any of this here, which what? Oh yeah, some crash because I waited too long, and yeah, you don't have to care about this. The code is alright, okay? If you didn't understand any of this whole collision stuff, and I'm not sure if I explained this properly, then seriously just ask, because I want you guys to understand what I'm doing here, otherwise this has no sense. This makes no sense. English. Okay, so thanks for watching, and hopefully see you in the next episode. Have some fun time programming this, and yeah, see you then.